Hi everyone, my name is Jiashun Li. Today I'd like to discuss a predictive analysis of credit risk using statistics and machine learning. Here's my entire research poster and I will present by each part. I'm a sophomore student at Purdue University Daniel Schools of Business. Here's my LinkedIn and email address. And my mentor is Professor Matthew Lennon. This project analyzed important factors that cause a loan applicant to have bad credit risk, such as loan duration, checking account balance, age, and so on. This is important for commercial banks to decide whether to grant loans to applicants and reduce financial losses due to loan defaults and bad credit risk. The motivation for this work is the rise in bad credit and loan losses among major banks during COVID. I built several models such as Nominal Logistic Regression model, K-nearest neighbors model, classification tree model, and support vector machine to predict whether a loan applicant will have bad credit risk. My prediction model also provides potential business value. I will estimate how much bad credit costs our prediction model will save for the bank based on the confusion metric. My predictive modeling and predictive analytics not only help commercial banks strengthen their credit risk management system and reduce loan losses, it could also give future loan applicants a basis of exactly what parts of the information will be vital to the loan approval process. Loans are the core business of banks. Banks' main profit comes directly from the loan's interest. In the recent years, the COVID-19 has had a great impact on economic development that also brought a negative impact on the banking industry. Large banks in the U.S. have seen rising default rates and bad credit risk on the credit cards and loans since pandemic restrictions and historic job losses began in the early 2020. According to the data collected by Bloomberg in Figure 1, top banks like Wells Fargo, Bank of America, Citigroup, and JPMorgan Chase have continued to increase available provisions for loan losses for the second quarter of 2020. The average loan loss provisions, or the maximum cost of bad loan defaults, for the four major banks in 2020 has reached approximately $6,160 million. The usual loan approval process is shown in the Figure 2. We can see that if the applicant has a great credit risk, he is likely to repay the loan and the bank can approve the loans. If the applicant has a bad credit risk, he is not likely to repay the loan. Then approving the loan to the person results in a financial loss to the bank, so it cannot approve the loans. So it makes sense for the banks to have a credit assessment of the borrowers. The main stakeholder of this study are the banks. My analysis method and prediction model can help banks decide whether to grant loans to applicants and reduce financial loss and costs due to the bad credit risk. Primary question we will research is what are the important factors that can lead to bad credit risk to a loan applicant. This is very typical binary classification problem. So we will use 4 classification models to data mine our predictors. By analyzing the relationship between input variables and target variable, we can compare 4 models and choose the best model to predict and classify applicant as good or bad credit risk. Our research questions are what are the important factors that can cause applicants to have bad credit risk, and how effective are predictive models in accurately predicting the bad credit risk. In the literature review, to gain a deeper understanding of risk management data, I refer 3 following articles. They are all timely published, and I have a better understanding from the forecasting model they apply. When exploring the data, I have less than 5% of missing values, and we impute them. There's no outliers in the dataset, and I standardized numerical data in the same scales using D-score standardization. A notable feature in my dataset is my target variable is a heavy unbalanced data with only 25% bad risk and 75% good risk. We can see in the Figure 4. We try to solve this using the SMOD to resemble, but unfortunately JumpPro doesn't provide SMOD. As a modeler, I will select appropriate statistical performance metrics during the model building and comparison to reduce the impact of unbalanced data. Here's the methodology. And I use the validation set approach to do the data partitioning. Here's 60% training set, and I set 20% of validation set, and the rest are 20% test set. And then I do the model building, and I identify candidate model and best model through the analysis of method correlation coefficient, AUC, and F1 score. Since our target variable is a binary classification data and there's a heavy imbalance between two classes, I choose Matthew Correlation Coefficient or MCC as my statistic performance measures. Here I define overfitting as having a trend and test difference greater than 15%. Thus, based on the definition, nominal logistic regression, KNN, and the classification tree are candidate model. But the SVM model is overfitting since the trend and test difference is 15.82%. In addition to the MCC, AUC, and F1 scores, there are three valid measures of binary imbalance classification data. To determine the best model, I will combine the three measures MCC, AUC, and F1 scores and compare the statistic performance of three candidate models on the test set. As we can see in the Figure 7 and Figure 6, nominal logistic regression model is the best model among three candidate models since it has the highest MCC, it also has the highest AUC and F1. Overall, it's performing fairly well compared to other two. By utilizing nominal logistic, we can see from Figure 8 that among these variables, long duration has the greatest impact on the getting back credit risk, followed by checking account balance, saving account balance, and age. Banks should give more consideration to these factors of the borrower. Meanwhile, I think another potential business application of this predictive analysis is to use the predictive model to make a better system to predict the credit risk of banks for future loan applicants to reduce losses. Figure 9 just demonstrates the overall financial savings if a bank decides to use our credit risk predicting model. Our model predicted 90% of actual bad credit as true, and only 10% are false positive. When combined with the information above, we predict that our model may save bad credit costs $5.544 billion, minus the false positive predictions, we get $4.928 billion saving. Here's the conclusion. There's still some limit of our project. Our model still have some room for improvement, especially in terms of higher MCC scores, and the SMART can further solve data imbalance and improve the accuracy of model predictions. Finally, this model should be updated every year, as the number of loan applicants and macroeconomic situation are generally different from year to year, and the approval threshold for banks changes accordingly.